Hi there. Today we're going to look at measuring angles. We've previously talked about measuring segments. Let's talk all things angles today. Now an angle is formed by, we probably know what an angle looks like and we in our head know what it means. Geometrically speaking, it's formed by two rays. You can see right here is a ray and here's another ray. Two rays that have the same endpoint right here, this point A. The rays are the sides of the angles. The endpoint that they share is called the vertex of the angle. Now we can name this angle in numerous ways. If there's just a single angle sitting there, we can just call it by its vertex, angle A. And we do this. We put a little angle in front of it and then a capital A, because that end point is a point, it's a capital letter. We can also name it by wrapping around the angle. And this is important. Sometimes if there's multiple angles going on all at one with the same vertex, you have to use all three letters in order to name it. And you wrap around it. You call it angle BAC, or you could name it CAB, as long as you wrap around that angle. And the vertex is always in the middle letter there. Okay, sometimes when you start having a bunch of angles, we simplify that process by just putting a number in there to indicate, oh, this is just angle 1. All right, lots of ways to name angles. Let's look at this example. This is what I was talking about when you have more than one angle going on with that same vertex. Here's this vertex M. Okay, so it says, what are two other names for angle 1? Okay, so for angle 1, I could not name it angle M because that's too vague. Angle M could also mean this angle over here, or it could mean the entire angle. It has different options, so we could not call this angle M. This would be that example where you have to use three letters and you have to wrap around that angle. So for angle 1, I could also call it angle JMK, or I could name it angle KMJ. Those are my only two other options there. Now let's classify angles. These are probably terms that you're familiar with from previous classes, even from middle school probably. Just an acute angle is going to be an angle that measures less than 90. A right angle that equals 90. Obtuse means it's greater than 90. And if it goes all the way to the point of being a straight line, we call that a straight angle. Let's practice using a protractor a little bit. You've probably used these before, but kids tend to get mixed up on which numbers you're supposed to be using. So let's look at this problem. It says, what are the measures of angle LKN? Well, they give me a whole bunch. Let's just start with the LKN. L starts here. K is my vertex. N. All right, since this ray over here lies right along the 0 line, and different protractors work differently. We'll practice here a little bit measuring on our own. This particular protractor has a hole right here, and it has a 0 line here. Sometimes the 0 line is the very edge of the protractor. You just have to look at your protractor and see, because you always want to line that up right there at 0. Okay, the next thing is do you use this number or this number? Which number am I using? Well, if you're starting over here on the right, you use this lower set of numbers, and it should kind of make sense because you're talking, okay, if I have an angle that's in here, these are acute angles. These would be less than 90. These angles are obtuse, and I am certainly not obtuse from this ray right here. Now, when I stretch this clear over to L like it wants me to, now that's an obtuse angle. That's greater than 90. So you can see these lower numbers increasing to, yep, there it is, it's obtuse. I would say that one falls right between 140 and 150. So that's a 145 degree. So maybe over here you could write, oh, and here's the next thing. Just like there's a special way on segments when you're talking about an actual number versus the angle, we'd write the measure of angle LKN. We put a little M in front of it. The measure of angle LKN is equal to 145. Okay, let's try again. Next one is JKL. JKL. Okay, so this one does not line up at the 0, so you just kind of have to look at, well, I'm at 90, and I'm going to make it to 145. How much did I just go there to get from 90 to 145? The measure of angle JKL would be 55. All right, last one, JKN. If you look at where JKN is, JKN. Oh, that's back to that 0 line, so I really can just look at the number. That's a 90. So the measure of angle JKN equals 90. Now it says classify each as acute, right, obtuse, or straight. Okay, so this one is greater than 90, so this one would be obtuse. This one's less than 90, it is acute. This one is 90, it's a right angle. The only thing I didn't have an example of is a straight angle. Could you look at this picture and pick out a straight angle? Okay, it would be angle NKH or HKN. That'd be your straight angle in that example. Let's practice measuring with a protractor on our own. So I grabbed this protractor here. It comes in here. The key thing when you're measuring it is to always put the hole or your 0 line, wherever that's at, put that right there at the vertex. So I'm going to come down here. And what I'm trying to do is I want to line up. Ooh, I wish that was more see-through. Okay, that's not ideal. Let me make sure I get that right. Okay, so right here is where that would line up. And I line up my 0 line, and then I'm going to use, because I'm on the right side, I'm lining up the 0 line over here at 0. Then I'm going to use these bottom numbers, 0, 10, 20. I'm just following this around, and I'm using the bottom numbers. So if I had to guess, and I can't really see very good right here, so I might be off a hair, but I would guess this to be at 120, probably 127 is what I would say there. So then I could say the measure of angle, oh, I didn't really name that angle, so I'm just going to say the measure of angle A, I don't know what it is equal to 127. Now that's kind of your basic angle. Let's look at different types of angles. Here's another one. This time the angle doesn't really have a ray that goes off to the right. It has a ray that shoots off towards the left. So what that means is I'm going to be using my, well, it's kind of like my 180 line, or really it's going to be a 0 line, but since I'm shooting off towards the left, instead of using the bottom numbers like I have been, I'm going to want to be using the top numbers. I'm going to want to start at 0, and it's going to, because you can look at this angle and see that it's acute, so I don't want my number to be huge, I want it to be a smaller number. So I'm going to grab that protractor, and I'm going to line that up right there on the left 0 line and look at what that measures. I'm looking at my top numbers here, going through 0, 10, 20, 30, oop, what do you think, 44, 45? I'm going to go 45. This looks closer to 45. So I'm going to say the measure of angle A is 45. All right, and then you have the option where there isn't really a nice horizontal line to line up my protractor with. So what I end up having to do is I have to rotate my protractor, because I have to have one of the rays, oops, that's not what I meant to do. I have to have one of the rays line up with my 0 line. So I'm going to take my protractor, and this will probably change sizes as I go, but that's okay. And I'm going to bring it down here, and I'm going to line it up and put the 0 line. The size of my protractor doesn't matter, as long as it just grows proportionally, I should be okay. Put the 0 line right there at 0. Now because I'm on the right side, again I'm going to be using the lower numbers, because I can tell this angle is an acute angle, so let's use 0, 10, 20, we're working our way up to, looks like about a 76 degree angle is what I'd write. So measure of angle A equals 76. Always have to line your protractor up on the 0 line, and then go from there. All right, let's talk about congruent versus equal. Same thing applies from segments. If their measures are equal to each other, then we're going to put this little m in front, say the measure of the angle, so maybe it's a 70-degree angle, and this is more like a 20-degree angle, 20-degree angle, and a 20-degree angle, then those measures are equal to one another. You're talking about numbers. But if you're talking about the actual angle itself and saying, hey, I could pick this up and lay it right on top of this one, and they would land on top of each other because their measures are equal. See the little arc here? Just like with hash marks, that's how we indicate that they are congruent to one another. So if they're going to have that same measurement where they're going to land on top of each other, I've got the arc to show congruent, then I'm going to do this congruent symbol, and I don't do the little m. I'm not talking about its actual measurement. Don't care what the number is. I'm just saying the two angles land on top of each other. That's congruent. Just like there is segment addition, we have angle addition, and it's the same idea. You're going to add the two little parts, it equals the big part. This is going to be your classic picture of where angle addition applies. You're going to have these two little angles that are next to each other. We call that adjacent because they share this leg right here. They're adjacent. They're right next to each other. And those two little angles, when you add them up, you can see here, the measure of AOB plus the measure of BOC. When you add those two up, it should equal the big angle, the measure of angle AOC. Let's try working through a problem like this. I'm going to bring this up so we have a little bit more space. All right, so it says if the measure of angle RQT, that looks like an O, but we're going to say that must be, they must want that to be a Q there. We'll just sneak a little Q in there. All right, so RQT is 155. That's the entire angle. That's the big part, 155. What are the measures of the two little angles, RQS and TQS? All right, so just like with segment addition, in angle addition, you're going to add the two little parts, 4x minus 20 plus the 3x plus 14. The two little angles should add up to equal the big angle they told me was 155. That's the geometry. Let's go do the algebra. Clean up the left side of this. This would all simplify, combine like terms. You got a 7x. You have a negative 20 and a positive 14. That's a negative 6. So cleaning up the left side gets us this. Now we're ready to start isolating the x. Okay. Divide by 7. I don't have my calculator handy. Let's see if we can do this. 7 would go in there 23 times, I think. Okay. So now that's what x equals. But the question was, what are the measures of the two small angles? So yes, this is part of the answer. Let's grab that and let's go plug it in and let's find the measure of angle RQS. So you're going to have to plug 23 in for x. All right, I'm going to cheat. I'm going to get my calculator because I don't want to take forever here. All right, so I'm going to take 4 times 23 and then I'm going to subtract 20 from that. And I end up at 72. So the measure of that angle is 72. The measure of the other angle that they want, TQS. All right, now these are not necessarily congruent to one another. They kind of look like they are, but it did not indicate that. So I don't automatically assume it's a 72. In fact, I'm pretty sure it's not. I'm going to do a 23, because that's what x is. I'm going to multiply it by the 3, and then I'm going to add the 14. And that gets me an 83. So those are the other two measurements. All right, so this is your chance to try. Go ahead and pause the video and get it set up, solve it, see if you can answer the question. They are again asking for DEC and CEF. Those are the two angles. And good luck. See what you can do. Pause the video. Alright, so I went ahead and set it up for you in case you needed a little help there. This one was different. They didn't tell me what the angle is, but they said it was a straight angle. So I know that a straight angle always ends up being 180. So I'm going to add these two and set it equal to 180. Now, if you had not gotten that, you didn't know what to do, alright, go ahead and pause the video and now see what you can do. If you already did that, then just wait it out a little bit. All right, so here are my answers. Go ahead and check and see if you agree. If not, take a minute, pause the video, and look through my work and see if you can figure out where you might have gone wrong. If you did all right, kudos to you. Good job. That's all I've got. So good luck. Go do your homework.